Ever get that feeling like you want to like really get to the bottom of something complex, you know? Cut through all the noise and just understand like the core ideas without getting bogged down in tons of detail.
Mm-hmm.
That's exactly what we're doing today on the deep dive. You've brought us this super fascinating area to explore how maps and text work together when we're learning.
Yeah. You're basically asking for like the cheat sheet to understanding how visuals and words team up, you know,
Oh, yeah.
in our brains
Uh-huh.
to help us learn more efficiently.
Right.
And to do that, we're going to dive into a really comprehensive overview of research
Okay.
called Learning with Maps and Texts, an overview by Verdi and Kulhavi.
Okay.
And this isn't something new. This paper is from 2002, and it synthesizes like 2 decades of findings
Wow.
from psychology and education.
Okay, so 20 years of research distilled down into this. So this is not just like somebody's opinion. This is actually built on something.
Right.
So our mission, I guess, is to extract the most valuable insights from this research and figure out how can this help us all learn better when maps and text are involved.
Exactly.
I love it. Let's get into it.
Yeah, and one of the most like powerful ideas that comes out of this is that maps aren't just these kind of decorative elements alongside text.
Right.
They actually play a crucial role in how we learn and what we remember.
Okay. So unpack that a little bit. How do they actually actively help us learn? What's the mechanism at play?
Yeah, so the authors draw on a couple of kind of foundational theories.
Okay.
One is called Kulhavi's conjoint retention theory,
Okay.
and the other is Paivio's dual coding theory.
Gotcha.
And the core idea here is that when you encounter a map alongside text, your brain isn't just processing the information in one way.
Okay.
The text is providing a verbal code. Right.
Yeah.
The map is providing what we would call a visual code, a spatial code.
So it's like hitting the information from two different angles at the same time.
Exactly. And what's really key here is that our brains can actually make connections between these two codes.
Oh, that's cool.
So visual elements on the map can be triggers for remembering things in the text,
Oh, interesting.
and vice versa. And this creates more pathways for later retrieval. It's kind of like how we remember a song, right?
Uh-huh.
Sometimes it's a particular lyric that pops into your head.
Yeah.
Other times it's the melody that brings back the words.
That's a great analogy.
Yeah. So this dual coding just gives you more ways to access the information.
And I even love how in the paper they actually have like figure 1, and it kind of lays out this model visually where it shows how the verbal and the map information are encoded separately, but they're also connected.
Right.
And then recall can kind of happen through either route or the link between them.
Exactly.
You can really see it visually.
Yeah.
But it's not just about the map and the text in isolation, is it? It's also about what we ourselves bring to the learning process.
Absolutely. And the authors delved into this in a section on what they call control processes,
Okay.
which essentially just means the cognitive functions we use when we're interacting with the maps and the text.
Okay.
And a major element of that is prior knowledge.
Yeah, that makes intuitive sense.
Yeah.
Because if you're looking at a map of your neighborhood, you're going to obviously process it differently than a map of some country you've never been to.
Right.
So what does the research actually say about how that impacts things?
Well, the research really supports that intuition.
Yeah.
So, for example, Lowe's study, he looked at how meteorologists
Okay.
versus people with no meteorology background interpreted weather maps.
Okay.
And as you might expect, the meteorologists, with all of their background knowledge about weather patterns
Right.
and map symbols,
Yeah,
remembered way more.
of course.
They had that schema in place already to integrate that visual data.
So it's like their existing knowledge was like a mental filing system.
Exactly.
Oh, okay.
But here's an interesting twist.
Oop.
Schwartz's research showed that if a map contradicts what you already believe about a place, it can actually hinder learning.
Really?
Yeah, so like your ingrained understanding can sometimes override the new visual information.
Wow. That's so interesting because you'd think a visual would just correct any misunderstandings.
You would think that, but our brains really like to hold on to what feels familiar and consistent with our models.
Right. So interesting.
And Allen and colleagues found something similar. They found that when individuals had a lot of prior knowledge of the geography being discussed in a text,
Mm-hmm.
the map itself had less of an effect on their ability to recall the text.
Wow.
They were already relying on their internal mental map.
It's like if you think you know the route already, you're less likely to look at the map super closely.
Exactly.
Yeah.
And then the studies involving American and Australian students,
Okay.
where they were learning about each other's countries,
Right.
And then they introduced this fictional country, Novadocia, and some text about cricket, which is probably unfamiliar to both groups.
Yeah.
The strongest recall was when students had familiarity with both the map's representation and the topic discussed in the text.
Interesting. So the familiarity really does breed, I guess not contempt, but breeds knowledge in this
Oh,
case.
exactly.
So prior knowledge obviously has this huge influence. What else is there under these control processes that affects how we learn with maps and text?
Well, another key aspect is task demands.
Okay.
And this includes the specific learning strategies that we use.
Okay.
So are we actively trying to link things on the map to the text, or are we just passively looking at both?
Right.
It also has to do with how we focus our attention and how much time we spend with the material.
Of course, because if you're just quickly scanning a map before a presentation,
Right.
that's very different than if you're really trying to internalize it.
Exactly.
Yeah.
And then lastly, our familiarity with maps themselves plays a role. So Kolfi and his colleagues did these think aloud protocols where people would kind of talk aloud
Right.
as they were looking at maps.
Yeah.
And it turns out that individuals who are more experienced using maps, they tend to be better at encoding and processing the visual information.
That makes sense.
And so they create more effective mental representations.
Right.
But interestingly, the research suggests that when it comes to learning really basic information
Oh, yeah.
presented on a map, the difference between those expert map users and novices isn't huge.
Huh.
So the expertise seems to become more important when you're dealing with like highly technical or unusual features.
Okay. That makes sense. So once we factor in like what we bring to the map,
Right.
let's talk about the map itself.
Yeah.
What specific features or structural elements within a map are really crucial for learning?
Well, this is where it gets really fascinating. The authors point to two main types of information that we extract from maps.
Okay.
Feature information
Okay.
and structural information.
Okay. So feature information sounds like the individual components that you see on the map. The icons, the labels, different colors representing something.
Exactly. It's kind of the what is located there aspect.
Okay.
And Bertin talked about these things called retinal variables, like color size and shape.
Right.
And these visual cues help us differentiate between those features.
Right.
And what's really important here is that this feature information, this is often what triggers our prior knowledge.
Okay.
It activates those mental frameworks, those schemas that we have.
Right. So if you see a little icon of a church on a map, you might immediately think of everything you know about churches
Exactly.
or towns or whatever it is.
Right.
So I would imagine then that the quality of these features is pretty important. A really vague, abstract symbol probably isn't as helpful as something that's really clear and realistic.
Yeah, and that's exactly what the research says. So Gokay argued that map symbols are really only effective if they're widely understandable and familiar.
Yeah.
So they have to be clear representations of what they signify in the real world.
Right.
And Downs kind of echoed this. He suggested that the closer a map feature resembles its real-world counterpart, the better we can use that information.
Yeah.
And Webb and colleagues, they actually did an experiment showing that maps with higher quality,
Okay.
more realistic feature representations led to better recall of the accompanying text.
Okay. That makes sense. The easier it is to recognize and connect with the visual, the better it links to the information.
Exactly.
Yeah.
And Johnson and her team did some really key work here.
Okay.
They compared what are called distinctive features,
Mm-hmm.
which are the ones that really visually resemble what they represent,
Okay.
with more non-distinctive symbolic features.
Okay.
They also looked at the impact of labels,
Okay.
having labels present or absent.
Gotcha.
And their key finding was that distinctive pictures combined with appropriate word labels
Okay.
resulted in the best recall for both the map features themselves and the text.
Wow.
So it's that combination of a clear visual and a clear verbal identifier.
That's really interesting. So clear, recognizable features paired with labels. What about structural information?
Right, so structural information refers to the spatial arrangement of those features.
Okay.
So the network they create,
Mm-hmm.
the distances between them,
Okay.
and their relationship to the map's boundaries.
Okay.
And research has shown that when features are more spread out on a map,
Okay.
so you're increasing that structural information or recall of both the map and the text actually improves.
So a map that's really cramped with tons of stuff all close together
Right.
is worse than one where things have a little bit of breathing room?
Exactly.
Okay.
And Stam and colleagues expanded on this idea. They said we should also consider what are called internal finds.
Okay.
So things like rivers, roads, other internal markings on a map.
Mm-hmm.
And they found that these internal lines can actually help us hook feature information and
Interesting.
establish internal boundaries. And this leads to better recall and a more accurate placement of those features.
So it's like using the internal elements as organizational tools.
Exactly.
That's really neat.
And the idea here is that this structural information helps us construct those really complete and intact mental images
Okay.
of the map in our working memory.
Uh-huh.
And Larkin and Simon argue that these visual images don't overload our cognitive capacity
Okay.
because we can shift our attention very efficiently across them.
Okay.
And so these intact mental images provide additional retrieval cues when we're trying to remember the text.
Right.
So it strengthens the connections between the map and the written information.
So it's like the way a map is actually laid out literally helps us build a mental framework
Exactly.
that then supports learning from the text.
Right.
I love it. Now, the paper also talks about this thing called the edge effect.
Yes,
That sounds intriguing.
it is.
What is that?
So the edge effect is this phenomenon where we tend to remember the features that are located at the edge of a map much better than the ones in the interior.
Really? And why would that be? It's not as if the ones on the edge are more important, are they?
Not necessarily. Rosano and Morrison did a bunch of experiments where they had people study maps and then try to redraw them,
Okay.
even like a week later.
Wow.
And they consistently found that features located along the border were recalled more often and with greater accuracy.
Interesting.
And they even noticed this kind of outside-in pattern of recall where people would remember the edges first and then work their way in.
Oh, wow.
Interestingly, internal lines, like those internal finds that we talked about, can actually act as internal edges
Oh, cool.
and improve the recall of nearby features.
So it's like our brain just gives priority to what's at the boundaries.
Yeah, it seems to.
Interesting.
And Johnson and colleagues found that if you actually enhance the edges of a map visually, it improves learning of features that are near those enhanced edges, and even the text facts that are associated with them.
Interesting.
And Verdi and his team did a really interesting study using maps of Tasmania,
Okay.
both with and without a defined border,
Okay.
and with key features either on the edge or in the interior.
Okay.
What they found was that features located at the edge were significantly better recalled than the ones in the interior,
Regardless.
regardless of whether the map had a border.
Wow.
So they took this to mean that the arrangement of the features themselves was allowing the participants to create their own mental boundaries.
Interesting. So even if there wasn't like a thick black line around it,
Right.
if the important stuff was toward the outside, it still had that effect.
Exactly.
That's so cool.
And this likely ties back to Schwartz's idea about the importance of that intact mental image for learning.
Right.
So the edge effect probably contributes to the formation of those mental images.
Gotcha.
Gives us a stronger framework to anchor the text information to.
So if you're designing a map, you might want to think about putting the most important stuff kind of towards the edges.
Exactly.
Very cool. This is all so insightful. Now, the paper also talks about how all this applies to the classroom.
Yeah.
What are some practical things that teachers can do with this information?
This is where it gets really applicable. One of the most important findings
Okay.
has to do with the order in which you present the map and the text.
Okay.
And research has really consistently shown that presenting the map before the text
Okay.
leads to significantly better learning outcomes.
Map first, then text. Why is that so crucial?
Well, the cognitive explanation goes back to those mental images.
Okay.
So when students see the map first, they can start constructing those really economical mental representations of the space.
Okay.
And then those images becomes scaffolding to help them process the text
Gotcha.
without overloading their working memory.
Okay.
If you present the text first, they're having to process all this information linearly,
Yeah.
which takes up a lot of working memory.
Yeah.
And then when they get to the map, they don't have the resources to encode the information effectively.
Yeah, it makes sense.
And they might end up prioritizing one or the other.
Yeah. It's like you want to build the frame of the house before you start filling it with furniture.
Exactly.
So map first, then text.
Yes.
What other classroom implications are there?
Well, another one is situated cognition,
Okay.
which is the idea that learning activities should be really similar to real-world tasks.
Okay.
So a great example of this is Griffin's study
Okay.
on campus navigation.
Hmm.
He had students learn the layout of the campus by actually walking the paths.
Okay.
And they did way better on navigation tasks than students who just studied a static map.
So physically experiencing the space actually helps.
It does.
That's interesting.
And Morris did this really cool study with middle schoolers where they created physical models of glaciers
Wow.
using clay and sand.
That's really creative.
Yeah.
So even when you can't be in the actual place, right?
Doing something more hands-on
Exactly.
really helps.
Exactly.
What about the role of technology?
Yeah, so Lynn's experiment compared traditional library-based research,
Okay.
creating maps by hand, with using the internet to research and create interactive maps.
Okay.
And he found comparable recall between the two groups.
Okay.
But the students who used the interactive maps reported enjoying the learning experience more.
Interesting.
So it could be a motivational benefit.
Yeah, because sometimes you can learn the same stuff, but if you actually enjoyed the process,
Yeah,
you're more likely to do it again.
exactly.
So the paper also ends with talking about some future directions for research.
Yeah.
What are some things people are still trying to figure out in this area?
Yeah, so they point to several avenues for future research. One is continued exploration of situated cognition.
Okay.
What are the most effective ways to do that across different domains?
Right.
They also suggest looking at Howard Gardner's theory of multiple intelligences.
And how that might apply to map learning.
So tailoring it to different learning styles.
Exactly.
Makes sense.
Thematic maps, which focus on specific data or themes, are also interesting.
Okay.
Researchers are still really digging into the edge effect
Okay.
and how we encode map boundaries in our minds. And of course, with the rise of digital maps,
Right.
there's a lot of research going on about how these electronic formats impact learning compared to paper maps.
Yeah. It sounds like a field with a lot left to discover.
It does.
So to wrap up this deep dive,
Yeah.
what's like the one big takeaway you want people to have about maps and learning?
Yeah, the big takeaway is that maps are way more than just visual aids.
Yeah.
They're powerful cognitive tools
Mm-hmm.
that can really boost learning and memory if we understand how they interact with text in our minds.
Okay.
They offer this dual coding advantage, right? Engaging both our visual and verbal processing.
Yeah.
And they leverage our spatial cognition to help us build those strong mental representations.
I love it.
Yeah. So whether you're a student, someone trying to understand a new place, or even just reading a news article with an infographic,
Right.
it's really worth being mindful of these principles. Think about the order map first, then text.
Mm-hmm.
Pay attention to the design of the visuals.
Right.
Are they clear? Are they distinctive? Are they labeled? And then recognize the power of building a mental map,
Yes.
even if it's just a rough sketch in your mind.
Exactly.
And this leads to a final thought for all of you listening.
Mm-hmm.
How might these principles of learning with maps and text extend to other forms of visual information?
Yeah.
Diagrams, charts, flow charts, blueprints.
Right.
How could understanding these cognitive processes actually enhance your ability to learn from all those things?
Absolutely.
So the next time you encounter a visual aid, take a moment and see if any of these insights resonate with you.
Yeah.
Awesome. Well, thank you so much.
Thank you.
I always learn so much from you.
My pleasure. And thanks to all of you for listening to The Deep Dive. We'll see you next time.